this video we will discuss shielding effect, which is also known as screening effect. First of all, we will see the definition of shielding effect: the reduction in force of attraction between nucleus and valence electrons by the electrons present in the inner subshells is called shielding effect. The reduction in force of attraction between nucleus and valence electrons by the electrons present in the inner subshells is called shielding effect. In order to understand a shielding effect, we will see this figure. This figure shows electronic configuration of lithium, sodium, potassium. Electronic configuration of these elements are given. Which element has more electrons between the nucleus and the valence shell? Lithium, sodium or potassium? Which element has more electrons between the nucleus and the valence shell? Yes, potassium. Potassium has more electrons between the nucleus and the valence shell. These electrons which are present in the inner shells. These electrons reduces or cut off attractive forces between the nucleus and the valence electrons. This reduction in the attractive forces between the nucleus and the valence electron, this is known as shielding effect or screening effect. So which atom has the greater shielding effect? Lithium or potassium? Which atom has a greater shielding effect? Of course, potassium has greater shielding effect because potassium has greater inner electrons as compared to lithium. Greater number of electrons are present in the inner shells of potassium as compared to lithium. So that's why potassium has greater shielding effect as compared to lithium. Now we will see the trend of shielding effect across the periods and down the group in the periodic table. First of all, we will see the variation of shielding effect in a group from top to bottom. As we move from top to bottom in any group of the periodic table, due to increase in the atomic number of electrons are increases. Due to increase in number of electrons, new shells are added to keep these electrons. So as a result, atomic sizes increases from top to bottom in any group of the periodic table. So due to increase in the number of electrons in a group, the shells are also increases. So the number of electrons in the inner shells, they are also increases. So as a result, shielding effect increases from top to bottom in any group of the periodic table. So what is the trend of shielding effect in a group? As we move down the group, shielding effect increases due to increase in the number of electrons in the inner shells. I hope this is clear. Now we will see the variation of shielding effect across the period as we move from left to right in a periodic table. As we move from left to right in any period of the periodic table, the number of shells are remain same. Number of shells are remain same. That's why the shielding effect does not change across the period. Shielding effect will remain same because number of shells are remain same. That's why shielding effect will remain same. I hope variation of shielding effect in a period is clear.